All right, welcome. This is period 2. And we're off and running. And the thing that we're going to do today is, number 1, we're going to have a look at the past homework. Now, I have students on campus here that are a day behind. So they just need to get caught up. And but I'm going to go through a couple of problems real quick on technique, how to approach a couple of the problems that's on the assignment sheet. So I'm going to look at a couple of those. And 2, then we're going to look at material properties. And this is going to be with axial loading. So there will be some definition of that as we go along. And I'm going to go back and forth between 2 things that you'll have access to. 2 things, one of which I'm starting to make some notes for an online book for free. And so it's kind of rough. I'm just started, so don't expect this to last very long in this term anyway. So let's start right off and get down to where we're talking about uniaxial. Means we have a force that's on one axis. So I've got 2 weirdos pulling on a rope here, and if we cut through, then from equilibrium we got to keep it, we've got to have a force in there, otherwise that person is going to be going off in that direction, because down here is some friction, right? And then there's a normal force, because then there's a weight, that person, right? So, but what we're focusing in here is on this part right here. What we've got is a rope. We're pulling on it. Or just think of a piece of wood you're pulling on. Straight. The cross section is the same all the way along. And so when we, I didn't want to do that. What I want to do is, this doesn't actually attach. Where is my scroll? Ah, okay. Gotcha. This is not the program I'm used to, so I said that last time, so I need to get up to speed here. I want to talk about, first of all, 2 force members. And this is going to come back to the homework part of this, so this is why I want to do a little bit of this at the very beginning, because of 2 force members. And why are they called 2 force members? And you need to be identifying those types of members in your problems, because it will simplify your problem solutions dramatically. So, actually, if we go down to here, you'll see that we have this front end loader, and we got this piece right in here, and we are looking at this piece right here, and so there it is. On the PDF it looks a lot better than this. And we've got a load that's being applied right through both pins, and it's a 2 force member. So back up here on the 2 force member business, we have no intermediate forces being applied and no moments on the ends, right? So friction would screw this up. Usually friction is relatively small, we ignore it, but you can't always. So I worked on a satellite system. Well, not directly on the satellite system. I did the vibration analysis for the vehicle and put it up. And one of the things that was messed up at one time was they had a Teflon quote frictionless joint that turned out not to be very frictionless. that just really screwed up the experimental results, and then made me have to do double the amount of work and yada, 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 and all that kind of stuff. It was really a big deal. So it's not always insignificant, right? But if you look here, if I sum forces vertically, we know that this value right here is going to be equal to that value right there. And if I sum forces horizontally, I know one of these is going in the wrong direction. However, if I sum moments around A or B, if I sum moments around here, AY, BY don't come into it, and you only have BX, and BX is going around like that, but that's the only thing that's happening. So you got L times BX equals 0, so BX is equal to 0, leading you to AX is equal to 0. So immediately I've gotten rid of actually 3 out of 4 unknowns. Okay? And it's really pretty important. So what we're going to do is I'm going to go back now and put some stuff up here at the top here on the homework. One of the problems, which was the tire problem, and I didn't make a copy of it, but it has an axle that comes over here, and they told us that this was 2,700 pounds. Then it comes up like this, and this is attached to that. It's got another member that comes over here like that, and that's attached to something else, and I think there's one that goes off here at some wacko direction, right? It's attached to something over here. We don't care. What they're asking for is what's happening right there. The thing to realize, and there was a piece that came into this, if I remember right. I didn't bring my book. Let me get that. Well, that was good. Do we still have sound since I dropped that? Since we had a little trouble with sound last time. We're getting there. There it is. Yeah. This is where the spring came in. So this is on page 42. And so we had this block over here. This went over here like this. And it kind of hooked into that. But then there was this block that came over here. I don't know. And you got a spring. Comes in here. This is not a two-force member because you got the middle, right? So you can't say that the force is just going along in that direction, even though you know the direction. So when I cut this off, and I've got my tire, I got my 2,700 pounds, when I come up to here, this is a two-force member. So when we cut it open here, we know that that force CD there, I think it's CD, yep, F sub CD is horizontal. And then down here, this is not a two-force member, therefore you've got a force going that way and that way, whatever you want to call it, which was B. Yep. Right? All you got to do is just sum moments right around that spot, and you got the answer. So it's just next to nothing. If you identify that it's a two-force member and what's not a two-force member. Otherwise, you're going to be doing lots of steps that will essentially do what I did with that. Here's why this is a two-force member example. Okay. So now we're going to add another one here. Now, one of the things I want you to do, and I'm going to look at 167 actually, and then you can apply it to 164. 167 is a very classical type of problem. It's got, I'm just going to use lines here. You got 50 pounds over here. And this is 7 inches, and this is 9 inches, and this is 10 inches.